Hi guys, welcome to our channel. In our last video, we have seen a very good JEE question and I hope you guys understood that. If you didn't see that question, I recommend you guys to watch it after this video because that question is very important and you may use that concept in some other JEE problem. So in this video, I got two important JEE questions on limits chapter. Let's get started, and on your screen, there is a question from JEE Mains 2019. So the question states that limit y tends to 0, root under 1 plus root of 1 plus y power 4 minus root 2 divided by y power 4. And there are four options. First one is the limit exists and it equals to 1 by 4 root 2. And the next one is the limit doesn't exist. The third one is it exists and the limit is 1 divided by 2 root 2. And the last one is it exists and it equals to 1 divided by 2 root 2 times of root 2 plus 1. So we have to solve this question. Okay. So here we can see that it is in 0 by 0 form. How it is 0 by 0 form? Substitute this with it will become 0. Okay. So just a minute, I'll take my pen. So it will become 1 plus 1 plus 0 minus root 2 divided by 0. So this is nothing but 1 plus 1 under root, it's 2, root 2. So root 2 minus root 2 divided by 0 is nothing but 0 by 0. So if it is a 0 by 0 form, you can use L'Hospital rule, right? You can pronounce it anyways, like people used to pronounce it like L hospital or sometimes L hospital. Okay, so I usually pronounce that as L hospital, so let's continue with that. Okay, but if you see the numerator, it is very complex and it takes a lot of time to solve these kind of complex numerators. That too, it has under root and again a root under it, so it's very difficult for us, and JEE examination is a very time constrained examination, so we need very optimized methods to solve this. Okay, so one of such methods is rationalization. That too, if the square roots are there, to eliminate them we should always use rationalization. Okay, so in JEE questions, in most of the JEE questions, I mean, if you properly rationalize and simplify it, you'll get the correct answer in less time. So let's get started with it. Okay, so the first step which I'm going to take is to rationalize the numerator. So limit y tends to 0, root 1 plus y power 4 minus root 2 divided by y power 4. Here I'm going to rationalize it. 1 plus root 1 plus y power 4 minus, it should be plus actually because you have to conjugate it, right? Root 2 divided by 1 plus, just repeat it again, root 2, right? Now we have successfully finished the first step of rationalization. Now let's multiply it. So you guys know this formula, of course you should be knowing it, but anyways I'm writing it once again. A plus b times a minus b equals to a square minus b square, right? So this formula we are going to apply. So assume that this is a, this is also a, this is b and b. So the answer will be 1 plus root of 1 plus y power 4 plus 2. It's not plus, it's minus. Okay, it's minus 2 divided by y power 4 into 1 plus root 1 plus y power 4 plus root 2, right? So this is the first step. Okay, we have successfully finished with the first level of rationalization. Now let's simplify it. Okay, so here 1 is there and minus 2 is there, so let's write it like root of 1 plus y power 4 minus 1 divided by y power 4 of 1 plus y power 4 plus root 2, right? It seems like this root is not the full root. This is still this only, and root 2 is a separate entity, right? And always remember that these are in limits only. Limit y tends to 0, and again here limit y tends to 0. Now let's eliminate this root. Which root? This root. This root in the numerator, and then let's simplify it once again. Okay, so let's multiply this with 1 plus y power 4. Here this time we have to write plus because we have to conjugate that, right? So it becomes 1 divided by, repeat that, 1 plus y power 4 plus 1. Now let's multiply this. So again, using the formula which I have mentioned above, we can write this as 1 plus y power 4 minus 1 divided by y power 4 into 1 plus root 1 plus y power 4 plus root 2 times 1 plus y power 4 plus 1. This is under root, right? So the denominator is kind of complex, but we have arrived to the formula because we have cancelled out these 1 and minus 1, and then y power 4 and y power 4 getting cancelled. So the final one is, again, it's a limit y tends to 0, limit y tends to 0. So we can write this as 1 plus root of 1 plus y power 4 plus root 2, 1 plus y power 4 plus 1. So this is the final answer. And now let's apply the limit. Okay, and now it's not in 0 by 0 form now. Okay, so we can directly put the limit. So applying the limit. So wherever y is there, we have to substitute the value of y as 0. So it will become 1 plus 0 plus root 2. Again, this is a separate entity. Let me write it separately for better clarity. And then root of 1 plus 0 plus 1. So this is nothing but it is 1 plus 1 root 2 plus root 2 times 2. So it is 2 root 2 times 2, it's nothing but 4 root 2, right? 4 root 2. So this is the final answer, and the option is the limit exists and it equals 1 divided by 4 root 2. So in this question, the main takeaway is nothing but rationalization and simplification. If the numerator or the denominator, anything, okay, basically the numerator only, if it is very complex, okay, always, and it contains root, that is another important point. If it contains root, then just go for rationalization blindfoldedly, because JEE will always, JEE question paper setters will always try to, keep a question which can be solved easily through rationalization and simplification. Okay, so try to apply these two for other questions as well. Practice more questions and get mastered with it. Okay, so with this question we have learned the importance of rationalization and simplification. Now let's go to the next question. This is the next question. For each t belongs to the set of real numbers, let t be the greatest integer less or equal to t. Okay, so we have to solve this limit. It looks kind of, intimidating, and it contains modulus and then greatest integer functions. And these two functions are a very favorite concept for JEE Mains question paper setters. They always try to include modulus function and then greatest integer function in that. Okay, so these kind of questions are most likely to come in JEE, and understand the concept and you can do it. You can recognize the pattern and solve the question. Okay, so let's get started with this question. Okay, I will tell you how to solve this question. So first, to solve the limit, we should put x equals to 1 plus h. That's our usual way of solving it, and it is a positive limit as well, so that's why we are putting 1 plus h. Okay, positive limit, and we have to change the limit from x tends to 1 plus to h tends to 0 plus. Right, that's the usual way of solving our limit. So limit h tends to 0 plus 1 minus, wherever this x is coming, substitute with 1 plus h. 1 plus h plus sine 1 minus 1 minus h sine of pi by 2 greatest integer of 1 minus 1 minus h, okay, divided by modulus of 1 minus 1 minus h greatest integer of 1 minus 1 minus h. Now let's simplify this. Limit h tends to 0, 1 minus 1 plus h plus sine of minus h sine of pi by 2 of minus h greatest integer, that 2, right, divided by modulus of h minus h and then greatest integer of minus h. So now we have substituted the h values. How to proceed further then? We know that we already know these things, right? Minus h, modulus of minus h is nothing but plus h. We already know this identity. We change the color of the pen. We already know this. Similarly, again, modulus of h plus 1 is nothing but h plus 1, right? These things we already know. So let's apply this and simplify it. Okay. So limit h tends to 0 plus, everything is 0 plus, guys. Okay. 1 minus h plus 1, right, using this one, modulus, apply it, you will get h plus 1 plus sine of, this is normal h, right, using this identity, sine pi by 2 of minus h divided by normal h greatest integer of minus h. Now let's simplify it further. So here you will get this as minus h, right? If you solve this, this and this will get cancelled, so you'll get minus h. Let me write it properly. Minus h, okay, plus sine h into sine of pi by 2 of minus h divided by h of minus h, that too greatest integer. Okay, so now let's simplify it further. Minus h plus sine of h into sine of pi by 2 into minus 1 divided by h of minus 1. Okay, now you may be wondering how this greatest integer of minus h became minus 1. right? Now I'll explain you how. Okay, so first, for the people who know the concept behind the greatest integer function, you may skip this part. But for the people who doesn't know, I will just explain you. Greatest integer of 2.3 is what? It is nothing but 2, right? Because the the greatest integer less than or equal to 2.3 is nothing but 2, right? Because 2.3, the greatest integer is nothing but 2, right? You cannot take 2.1 or something because it's not an integer, it is a decimal. Okay, it's not an integer. So we should take 2, right? If it is 2.4 also, you have to take 2. If it is 2.9 also, you have to take 2 only, because it is the greatest integer less than of 2.9. In this case, it's 2.4. Okay, similarly for negative numbers as well. 1.2, greatest integer of 1.2. What is greatest integer of 1.2? It is 2, minus 2, because minus 2 is less than minus 1.2, and it is the nearest greatest, like it is the nearest greatest integer function, which is less than minus 1.2. Okay, then what about greatest integer of 0.1? The answer is minus 1, as you guys guessed correctly. It is minus 1. Again, greatest integer less than the minus 0.1 is nothing but minus 1, right? What about this minus 0.01? What about this number? Yes, again it's minus 1 only, because it is the greatest integer less than or equal to minus 0.01. Okay, so this is the concept. Okay, so how we are concluding that minus h, greatest integer of minus h, is equal to 1 when h tending to 0 plus. Okay, so h tending to 0 plus means we can write h is greater than 0, right? Of course. Then this is because h tends to 0 plus, right? So we can also say that minus h is less than 0. Just conjugate this, right? When h tends to 0 plus. Okay, this also satisfies, this also satisfies. Am I right? So we can tell minus h is slightly less than 0, right? So minus h is slightly less than 0. So for example, minus h can be 0.1, minus h can be 0.01, minus h can be 0.001. These are all just examples. Minus h can be anything which is slightly less than 0. So similarly, then what about the greatest integer of these, which is nothing but minus 1? For everything it's minus 1. Am I right? That's why I'm concluding that minus h is nothing but, the greatest integer of minus h is minus 1 when h tends to 0 plus. That's how I conclude this. Are you getting the point? So those who doesn't know, I hope you guys understood this concept. Okay, so with that we can solve this even more easily. Let me copy this. This was the equation. Okay, so now let's proceed further. So this becomes minus h plus sine h sine of minus pi by 2 divided by minus h, right? Now sine pi by 2 is what? It is minus 1. So minus h plus sine minus pi by 2, I mean, okay? Sine minus pi by 2. This will become minus 1 divided by minus h, and this minus gets cancelled. So, and guys, remember to put limit h tends to 0 plus always. Okay, these are all in limits only. So limit h tends to 0 plus minus h plus sine h divided by h. Now it's very easy to solve it. So just separate the fractions and then apply the identities. This is nothing but 1 and this is nothing but when it's tending to 0 you'll be getting 1. So it's nothing but after applying the limits you'll get minus 1 plus 1 and it is 0. So the answer is 0. Right? So the answer is 0. So this is the question which I wanted to solve. And this question and these two questions are very important because we have learned the importance of rationalization and simplification and then how to approach towards the modulus and then greatest integer function. So here the takeaways are handling greatest integer function GIF. I always write GIF when there is a limit. Right. So this is the main key takeaway. Right. So I hope these limits questions are very important. The last video one and then these three questions are very important in the aspects of JEE standards. Okay, so in the next video we will be solving questions on continuity, and then in the next video after that we will be solving questions on differentiability, and then we will be winding off with the continuity, limits and then differentiability chapter. Right, so I'll see you guys in the next video. Meantime, practice a lot of questions. Thank you so much.